The question says, follow the steps for graphing a rational function to graph the function. So we are given Rx equals 3x plus 3 divided by 5x plus 25. The first part, so this exercise has multiple parts. So part A says, if needed, first write the given function as a single rational expression. Then factor the numerator and the denominator of the function. Okay, so if I take a look, oh, this is kind of, we'll see. So at the numerator, right, I have 3x plus 3. If I factor the GCF out, that will give me 3 times x plus 1. At the denominator, if I factor the GCF out of 5, that will give me x plus 5. Because what I did was 3x plus 3 both have a GCF of 3, so that's x plus 1. And then 5x plus 25 both have a GCF of 5, so that is 5 times x plus 5. Now if you notice right here, nothing simplifies, nothing cancels out or anything like that. So in factor form, this is my answer. So I have simplified a little bit more. In a sense, I have rewritten it in factor form. All right, so then I am going to scroll down and we're going to go to part B. Part B says, find the domain of Rx. Okay, so I'm just going to go ahead and write the function here. So I have Rx equals 3x plus 3 over 5x plus 25. Well, this is a rational function, and with a rational function, we want to check what are the numbers that can make the denominator equal to 0. So I take the denominator, set it equal to 0, and solve. So I have 5x equals negative 25. Divide both sides by 5. X cannot be negative 5. So I'm going to write my answer in integral notation. Okay. So that will be from negative infinity to negative 5, u negative 5 to positive infinity. Okay, that makes right there undefined. All right. And then part B says, write the function in the lowest term. It is already in its lowest term. So for this, I am simply saying it is already in its lowest terms. All right. So then let's take a look at the next question. It says locate the intercepts. So again, just so I can have it right here, I'm writing my function again. Okay. So I'm looking for the x and the y intercepts. So if I'm looking for the x intercepts, I am going to substitute 0 for the y. And if I'm looking for the y-intercepts, I'm going to substitute 0 for the x. Okay, so first let's look for the x-intercepts. So r of x represents my y. So this is y. So 0 equals 3x plus 3 over 5x plus 25. You know what? This is two fractions equally to each other. So I'm just going to go ahead and put this over 1. And I'm going to cross multiply. Yep, I'm going to just cross multiply. So I can solve for x. Okay, I'm just going to cross multiply. So I have 0 times 5x plus 25. That's just 0. And then I have 1 times 3x plus 3. So that's just 3x plus 3. I'm going to minus the 3. So I have negative 3 equals 2x. And then divide by the 3. So x equals negative 1. That is my x-intercept. X equals negative 1. So this is the x-intercept. Okay. Now to find the y-intercept, I am going to substitute 0 for x. Okay. So I am substituting 0 for x to find the y-intercept. Okay. So 3 times 0 is just 0, plus 3, 3. 5 times 0 is just 0, plus 25, 25. So my y-intercept is 3 over 25. So my x-intercept, this might be too bright, is right here. My y-intercept is right here. Okay. Let's see the next part. What is the next part? Determine the behavior of the graph of R at any of the x-intercepts. Okay. So again, I'm just going to go ahead and write this down so we can see it. This is the function that we are working with. (5x plus 25). Okay, and we agree that to find the x-intercept, we have 0 equals 3x plus 3, right? So when we solve for this, we have x equals -1. For here, the exponent, the highest exponent right here is 1, right? We don't see it, but we know it's there. So that means I have a multiplicity of 1. 1 is an odd exponent, therefore it will cross the x-axis, all right? So at -1, it will cross the x-axis. There's no any other x-intercepts, so that's what. So that's for that part, okay? And remember again, this right here, we don't see it, but invisible 1, invisible exponent of 1, okay? All right, so let's go to the next part. We're doing part F right now. Determine the vertical asymptotes. So again, I'm just going to go ahead and write the function for us. Something going on with the, it's kind of slow, the pen. I don't know what's going on. Oh, hopefully the video records. 3x plus 3. Oh, I don't know. Something's happening. And I cannot make this video any shorter. Maybe the computer's like, oh, we're tired. We don't want to keep working. Okay. So to do for the vertical asymptotes, I am taking the denominator, right? I already checked. This cannot simplify anymore. Because remember, we need to check if we need to factor to cancel some of those terms. But in this case, nothing will cancel. So I'm taking the denominator. Set it equal to 0. And when I solve, I get -5. So there is a vertical asymptote at -5. Okay. Then we're going to go next. It says determine if there's a hole. Based on what we have learned, there's no hole because we would nothing cancel. When we factor it out, nothing cancel. Therefore, there's no hole. So no. Okay. Says determine the behavior of on either side of the vertical asymptotes if any of them exist. So we had a vertical asymptote. So we have 5x plus 25 equals 0, right? And that had a vertical asymptote of -5. The exponent for this right here, again, is 1. So that would say that I have a multiplicity of 1, okay? Which is an odd number. But what they want for this is specifically, okay? So 1 is an odd number. So when we're talking about the vertical asymptotes, not related not completely the same as the x-intercepts, okay? So if it's an odd multiplicity, oh, this is a lot to write. If it's an odd multiplicity, so if and this doesn't want to write very odd multiplicity, so I'm just gonna add multiplicity, then that means the graph, this is not writing very well. The graph approaches positive infinity on one side of the asymptote of the vertical asymptote. Oh, spell that wrong right there. That's a Y, asymptote. Okay. And negative infinity, this looks so bad. On the other, oops, on the other side, all right? So, and we'll see this in a later part when we are graphing it, okay? But an idea is that when you have odd multiplicity, the graph will have a general idea of looking this way. This is not working very well. Okay, so when you have odd multiplicity, the graph will have this kind of looking, okay? Something like these, okay? They're supposed to be the same, but okay, you guys know my bad drawing, right? So with odd multiplicity, the graph will approach positive infinity on one side of the vertical asymptote, that is right here, and negative infinity on the other side, okay? Now let's go to the next part. Now we need to determine our horizontal asymptotes, okay? So again, if I go ahead and take my function and write it here, I have 3x plus 3 over 5x plus 25, okay? And if I think about the rules for horizontal asymptote, I notice that the degree of the numerator equals the degree of the denominator. Therefore, I have a horizontal asymptote, okay? I do have a horizontal asymptote. Add y equals the coefficient of the top of the coefficient of the numerator from the leading term divided by the coefficient of the denominator from the leading term. In this case, that will be y equals 3 over 5. Okay, so I do have a horizontal asymptote at 3 over 5. And then if I have a horizontal asymptote, I do not have an oblique asymptote. Okay, so then let's move on to the next part. Okay, it says determine the points, if any, at which the graph of R intersects a horizontal or oblique asymptote. So we determined in the previous section that we have a horizontal asymptote at y equals 3 over 5. Okay? So what I need to do is take this 3 over 5 and set it equal to the function. So I'm going to rewrite it as 3 over 5 equals my function, which is 3x plus 3 over 5x plus 25. I'm going to cross multiply, so I have 15. This is not writing very well. Let me erase that. I don't know what's going on with the pen. It's kind of like losing connection. Okay, so I cross multiply. Here. Okay, so then that leaves me 3 times 5x is 15x. 3 times 25 is 75. So plus 75 equals 5 times 3, 15x. And 5 times 3, 15. Okay, so now I'm going to combine line terms. So I'm going to move this x. Move this x. The x's are going to cancel. So I am left with 75 equals 15. Is this true? 75 equals 15? No, it is not. So there's no intersection. No intersection. Okay? For it to be true, it has to give you a number, like a point. Okay? But in this case, no point. All right? So the next part, moving on, we are almost done. Use the real zeros of the numerator and denominator of R to divide the axis in intervals to determine whether the graph of R is above or below the x-axis by choosing a number in each interval and then evaluating R. So let's see how does this graph looks. Let's have an idea. Let's write down everything we know. Okay, so I have my, oh my God, I cannot make a straight line. Let's read that. Oh, imagine this is a straight line, okay? Imagine it's a straight line. Okay. So what do we know? We know that there's a vertical asymptote at -5. X equals -5, okay? So I have 1, 2, 3, 4, 5. Okay, so right here, imagine this is, oh no, it cannot be like that bad. It cannot be that bad. So it's supposed to be a dotted line, but I can't even barely make it straight. So this is very bad. Just know that it's a straight line. X equals -5. Okay? What else do we know? I know I have a y-intercept at -1, 0. So I have a y-intercept right here. I mean, an x-intercept, my apologies, an x-intercept right here. And then I know I have a y-intercept okay, y-intercept of 0, 3/25. Okay? So, and what is that as a decimal? That is just 0.12, very small, 0.12 for this. 0.12, okay, as a decimal. All right, so that is somewhere, so we have, let's say 1, 2, 3, 4, something, right? I just put some lines here. Imagine this is all very beautiful and pretty, okay? Go ahead and just do that. Imagine that everything just looks straight and perfect. So that y-intercept is just somewhere over here. Okay. And then we also have a horizontal asymptote, right? At y equals 3/5. And that is 0.6. So that is somewhere, let's go back to orange. Somewhere, just somewhere there. Okay, and again, these are supposed to be dotted lines, but you know, can barely make it straight. So this is y equals 3/5. All right? Okay, so far we have put everything we know. Okay, I also know my domain, -infinity to -5, union -5 to +infinity. Okay? Okay, so now I need to find, let me switch colors. I need to find some intervals that will help me determine when the graph is above or below the axis. Okay, so the first interval that I am going to look is from -infinity to -5. I want to know from left off, let's erase that part, whether the graph is right here or whether the graph is right here. And then the next interval that I am going to check is going to be from -5 to positive infinity. Okay, now, if you think about it, right here, the x-intercept tells me that it's going to cross. So whether it comes down this way or it goes up this way, okay? It's going to be determined on where is it, if it's here above or if it's here below, okay? Now we know that there's no intersections with the horizontal asymptote, okay? So now I'm just going to pick, in this interval, I am just going to pick the point -7. Okay, let's just put -7. Okay, when you take -7 and substitute it into the original function, which is r of x equals 3x plus 3 over 5x plus 25. Like when I take -7, I'm substituting it for this x right here. So I'm saying 3 times -7 plus 3 divided by 5 times -7 plus 25. Okay, when I do that, the y value that I get is 18 over 10, which is a positive number. Therefore, it's going to be above. Okay, so my graph is going to look somewhere here. Okay, above. All right, then in the next interval, I'm going to pick +2. All right, something's happening with my loop. I'm going to pick +2. So when x is 2, when I do that, oh, what value do I get? I didn't do that calculation apparently. So that is 9 over 35. So I still get a positive number. Okay. But now remember, I want you to take in consideration this right here. This area is above the x-axis, all right? And I also know that it's not going to cross this horizontal asymptote. So my graph will look something like this. Again, these are good lines. These are supposed to be good lines. Think about them as beautiful, good lines, okay? So now the last part, it's simply just you picking the graph from the multiple choice. But, you know, I'm not going to go through the trouble of graphing this again. So your graph will look something like this with beautiful lines and perfecto. All right, let's go ahead and stop this.